Okay, so this is day 2 of notes of this unit. We're going to look at solving radical equations with 2 steps. You should have watched the 1-step equations yesterday, and I'll define exactly what I mean by that. So if you're following along day by day, this is notes for 324. Okay, and we're solving 2-step radical equations. Now, if you don't have any paper that you're solving these on, any just notebook paper, whatever you're taking notes on, go ahead and pause the video now and get that, so that you have something to write all this down on. If I'm going too fast, please make sure that you're pausing it and getting the information that we're trying to get on there. Also, just want to let you know that you need to be checking your email. You also need to be checking Canvas on a regular basis. That's kind of how we're going to be, at least me, how I'm communicating to my students. Okay, so getting into the note stuff. So we're going to look at solving 2-step radical equations. The big thing on this is on the 1 step that you did yesterday, the first step was to always square it to get rid of the square root. Now we're going to have to do something else before we actually square it. So an example, if a 1-step equation that you might have possibly seen yesterday might have looked something like this. The square root of x minus 4 equals 3. So I would square both sides. I would add 4 to both sides. So I get x equals 13. And then I could put that in for x to make sure that solution works. So that's going to give me the square root of 9, which is 3. Okay, so that tells me that x equals 13. That is going to work for this. So what we're going to be calling a 2-step problem, might look something like this, where you have the square root of x minus 4 plus 7. Sorry, why don't we do minus 7 equals 3. So the first thing I'm going to want to do, and we'll write these steps down here in just a second, the first thing that I need to do is to get the radical by itself. So I'm going to take that right there, that square root of x minus 4, and I want to get it by itself. These steps are very similar to if I had x in there and I'm solving for x, then I would just add 7. And I'll expand on that a little bit more, just kind of that mindset. So the first thing I'm going to do, again, is I'm going to add 7 to both sides. So now I have the square root of x minus 4 equals 10. I'm going to square both sides, so I have the square root of x minus 4 equals 100. And then I would add 4 to both sides. And then after that, if I would need to, I would plug that back in for x to check to see if it's extraneous, which it's not. That's going to be the solution on this one. Okay, so whenever you're looking at these, the first thing that you're going to need to do, the steps to solve these, the very first thing you're going to do is you're going to isolate the radical. And if you're thinking again, whatever the steps you would take to solve for x, it's just kind of think of it as I'm solving for the radical instead of that. Second thing you want to do is you want to get rid of the radical. So on the examples above, I squared both sides to get rid of the radical. And then that way I can solve for x that's underneath it. After that, once the radical is off, you're going to solve for x. Once you have x solved for, you're going to check for extraneous solutions. So, let's go through a couple examples here. Let me kind of divide my board. There we go. Okay. So example 1, we're going to solve for x. In this equation, 4 equals the square root of x minus 7 plus 2. So again, I need to move everything away from the radical. I want to get rid of that, I want to isolate my radical. So I'm going to do SADMEP on everything outside of that red box, which the only thing I can move over now that I need to move over is that plus 2. So I'm going to take that and I'm going to subtract 2 from both sides. Whenever I do that, that's going to leave me with 2 equals the square root of x minus 7. I'm going to square both sides. So whenever I square the square root, that gets rid of itself, or that gets rid of the radical. Then I've got 2 squared, which is 4, equal to x minus 7. I'm going to add 7 to both sides, so x equals 11. Whenever I have that, I want to plug 11 back up into the original equation to make sure that that is what it gives me, that solution works within that problem. So I'd have 11 minus 7, which is 4. The square root of 4 is 2. And 2 plus 2 equals 4. So that tells me that x equals 11. That solution works. Okay. Next, going to the next example here. So on example 2, we're going to look at 6 equals negative 2 times the square root of x minus 3. So again, on this one, I need to isolate the radical. It's the very first step, so that red box that you see on the screen. So that means I need to divide both sides by negative 2. So I get negative 3 equals the square root of x minus 3. Now whenever you're doing this, a lot of people will be able to notice that at this point in the process, this problem, that, okay, I've got the square root, my radical is isolated, and it's telling me right now that that is equal to a negative number, which that cannot happen. So right now a lot of people will be able to look at this and say, okay, it's no solution. I can't take the square root of a negative number. Square root of a number and get negative 3. But we're going to go ahead and solve through it all the way, just as we would. So I'm going to square both sides. Whenever I square negative 3, That's going to give me positive 9 equals x minus 3. I would then add 3 to both sides. So x equals 12. So going back and checking or proving that that is an extraneous solution that would not work in this situation, I'm going to plug it back up into the original problem. So I've got 12 minus 3, which is going to be 9. The square root of 9 is 3. Negative 2 times 3 is negative 6, which does not equal positive 6. So 12 would not work. Okay. But I know all that stuff kind of shrunk, so if you need to go back and you can't really see that on your screen very well, especially if you're looking at a phone, you can go back and pause the video so that it's larger. I just kind of shrunk it so that we could go on to the next problem and would have room for it. So for example 3, we're going to solve 10 equals 3 times the square root of 2x minus 4 minus 8. Now, if you'll just you don't have to write this down, but just watch me on the screen. And this is kind of what I was meant earlier. Whenever you're solving or isolating the radical, the steps are very similar to solving for x. So if I take this whole radical and I move it out and I put an x in there instead, the steps that I would solve for x, which is going to be add 8 and divide by 3, those are going to be the exact steps I'm going to take to get that radical by itself, it's what we've done on the previous 2 problems. It's just that was only one thing. On example 1, we subtracted 2. Example 2, we divided by negative 2. So on this one, the first thing I'll need to do is add 8 to both sides. So that's going to give me 18 is equal to 3 times the square root of 2x minus 4. And give me just a second, I'm going to move this work to a different spot where I'll have more room to work. There we go. So now I'm going to divide by that 3. 18 divided by 3 is 6. So now I'm done with step 1. I've isolated my radical. Next, I want to get rid of the radical, so I'm going to square both sides. 6 squared is going to give me 36. I set that equal to 2x minus 4. And then now I'm just going to solve for x. So I'm going to add 4 divided by 2. So the adding 4 is going to give me 40 equals 2x. Dividing by 2 is going to give me x equals 20. So there's all the original work for solving for x. And now what I'll need to do is I'll need to take that solution that I found and check for the extraneous solution. So I'm going to have 10 equals 3 times the square root of 2 times 20 minus 4 minus 8. And so I'm going to do everything under the radical first. So I'm going to have 2 times 20, which is 40. Minus 4 is going to be 36. The square root of 36 is 6. That will give me 18 minus 8, which is 10, which is what the original equation said it should come out to. So that tells me that x equals 20. That is the solution for that. So this is just these are just 3 examples of going through this. The practice problems that I'm going to get you, make sure you write these down. And then you can do these on a piece of paper. And then take a picture and submit these onto Canvas for this day. So problem number 1 is going to be 12 equals the square root of x plus 4 plus 9. The next one I'm going to want you to work is 10 equals negative 4 times the square root of 2x minus 3 plus 2. And then the third problem is going to be negative 4 equals 2 times the square root of x plus 9, x plus 4 minus 10. Okay, so as you're going through these, make sure that you are following the steps that we talked about over here, and make sure that you're doing the extraneous solutions. Even if you get to that point I talked about whenever we're on example 2, how we got to that step and I was able to look at that and say, well, it says the square root is equal to a negative number, so I know it's going to be no solution. I'm not going to get an answer to this. You still need to go through this process of proving that that is an extraneous solution. Okay, so here's the notes. This is for Tuesday, March 24th. Going over solving 2-step radical equations. So if you have any questions over this, feel free to email your teacher for any clarification on it.